This is week 11, lesson 2. For this particular lesson, you will be finding volume and surface area of three-dimensional solids. The formulas that you'll need are right up there at the top of the notes. Again, you can pause this and hopefully you've already printed this out so you can, write whatever you need to. The first thing I want to say is I will be unbelievably lenient on units. All right, so even though volume should be whatever the unit is cubed and surface area should be the unit squared, I probably won't mark you down on those at all. In fact, I guarantee that I won't. And this particular assignment is done in Schoology, and I don't want you to type in the units. I'm more concerned with, can you get the right number? All right, so just sort of be kind if I don't put the units, because I will be kind to you if you don't put the units. So let's start with example number 1. Okay, first thing is that we have a pyramid, so which means I'm going to be using the formulas at the very, very top. I'm just going to go ahead and start with the volume one. So volume is going to be, and again, I'm just filling in the formula, 1/3 the area of the base. Okay, so this particular shape has a base that is a rectangle, right? A base of 4 times 5. So I'm just going to go ahead and put 20. And then the next part of the formula here is the height. And this one, the height is given to you as 6. And if you multiply that all together, you'll get 40. Now, again, it's supposed to be centimeters cubed. If you don't have that, I'm okay with that. And when you do it in Schoology, there is no place for you to put that in anyway. All right. Next, as far as surface area. Okay, so the surface area has this formula up here. First, I need the area of the base, which I already know. It's 20. We just did it a couple seconds ago. Plus, now if you're looking at this formula, it's the number of sides of the base, right? That's what n is for these triangles. Now, here's what you need to think about. There are 2 triangles that have a base of 5, right? There's one base right there, and the other one's over here sort of hidden. And then there's 2 triangles that have a base of 4. That would be here and here. Okay, so we're going to have to do this sort of twice, right? There's going to be the 2 triangles that have a base of 4, right? So the area I'm looking at, let me see if I can shade this in. This triangle right here, right? It's sort of that face right there. There's 2 of them. So I have the half of the base times, now I need the height right here of this triangle, which I don't know right this second. I'm going to have to use this right triangle sort of, and again, you're going to have to sort of think 3-dimensionally there to figure out that hypotenuse. So let me draw it over here. Okay, so this is what I'm trying to figure out, right? This is sort of, I'm going to call it the slant height. The this bottom number right here should be 2.5, and the height is over here. That's a 6. I'll let you figure that out, you guys. Okay, it should be 6.3. All right, and then there's the 2 other triangles, right? The ones over here, I'm going to see if I can shade this in green. Okay, bear with me, guys. I'm going to see if I can eliminate some of these, but if I do, it's going to eliminate too much. I can't. Hold on. There we go. Okay, so the other triangles, which are here, right? That triangle, there's 2 of them. Half the base, which is a 5. Sorry about that. Let me erase. And again, now I need this height, okay, which we'll call the slant height, which will also depend on this and this. So I'm going to draw sort of a separate triangle here. The base on that is 2, the height is 6, and I'm looking for this slant height, which ends up being 6.5. Again, I'm assuming you can do the Pythagorean theorem, okay? If you're not getting that, right, if you're not understanding where this number and this number are coming from, then I'm expecting you to ask during class, whether you're in person or on Zoom, okay? Again, I'm assuming you can do this part. If you break out your handy dandy calculator, you should get 77.5. And again, this would be centimeters squared. I'm not too concerned about the units. Okay, for the next example, we will need these particular formulas. You may not be able to see them once I scroll this up, but you'll have them on your paper. So scooting this up. Okay, volume and surface area. So let me start with volume. Okay, the 1/3 is part of the formula. The pi, again, part of the formula. The radius here is a 1, so let me put a 1 in there and square that. And then the 3 is the height, right, which again was given. And if you plug all that in, you get pi, which is very accurate, but if we're rounding to 3 significant figures, it would be 3.14. Okay, now as far as the surface area, all right, again, there is a formula up there. It's pi times the radius squared plus pi times the radius, which is 1, times the slant height. Okay, S is slant height, which again, I don't know, but there is a little right triangle sort of peeking at you there with a leg of 1 and a height of 3, which would give me this slant height, which you can figure out to be rad 10. And breaking all of that into your handy dandy calculator, you should get 13.1. Okay, and then for this last example, and again, you may have to flip your paper over or write the formulas down, but for volume of a sphere, it's 4/3 times pi times the radius cubed. And again, handy dandy calculator, you should get 905. And surface area is 4 times pi times the radius squared. And handy dandy calculator, 452. Okay, notice I didn't put units on purpose because when you go to Schoology, you will not be putting units in either.